It's your boy, Gradius, coming at you live. And this is the video on 10.1 dilations. So, first we need to figure out what a dilation is, and then we're going to learn how to actually apply a dilation. Okay, and it's actually very simple. So, first, a dilation is something that it's basically when you change the size of a shape. Okay, so you basically make an image bigger or smaller. Okay, when we make an image bigger, we call that an enlargement. We're enlarging it. And then when we make an image smaller, we reduce the image, or a reduction. Okay. Now, basically what we're doing is if I take this triangle here, I want to dilate it to make it this triangle. I am keeping the same shape, but now I'm making it bigger. So these triangles are supposed to be the same shape. They're supposed to have the same angle measurements. Okay, but now the side lengths are going to be different because I'm making this smaller triangle into just the same exact shape, but a bigger triangle. Okay, so it's again, it's like if I take a square and then I make a bigger square. I kept the same shape, but now I'm just changing the size of it. Or again, I can take a square and now make a smaller square. Kept the same shape, but I reduced it and changed the size of it. Now, how we know what to change, how big or how small to change the shape by, is what's known as the scale factor. That tells us how much we need to how much we need to enlarge the image, or how much we need to reduce the image. So it tells us how much bigger we make it, or how much smaller we make it. Okay, and that's what we're going to be using to perform our dilations. Okay, so this is the fourth type of transformation. We've learned reflections, translations, rotations, and now we're learning the dilation. Now, here's the examples that we have. We have the vertices of image triangle A, B, and C, and we're going to dilate it by a scale factor of 2, and we're going to draw the image. So here's what we do for dilations is we need to have our original points. I see my original points, but I need to actually physically write them down. So my original points are A is at 2, 1, my X is 2, my Y is 1. B is at 1, 2, 3, 4. And then my Y is at 1, 2, 3, 4, 5, 6. And and then C, see this is at 4, so this is 5, 6. And this is 1, 2, 3, 4. So C is at 6, 4. So there's my original points of my image. The scale factor is 2. So for a dilation, what we're doing, and I'll write down the algebraic formation of this, what we're really doing is we're taking our X and our Y, and please, this is an important piece right here, and I am just multiplying both my X and my Y by whatever my scale factor is. I'm going to call that SF, scale factor. Scale factor. I am multiplying each point, each value by 2 because that's what my scale factor is. So, going back to my original points, my original point for A was 2, 1. So if I perform my dilation is a scale factor of 2. My new A is now going to be whatever this whole point is times 2. So I do X times 2, 2 times 2 is 4, 1 times 2 is 2. So my new A is going to be at 4, 2. 1, 2, 3, 4, 1, 2. There's my new A. And I just graphed it right there. Now let's do this with all of these. My new B, if I multiply everything by 2, this is going to be at 8, 12. And my final new C is going to be at 12, 8. I just multiplied every single one of these by 2. So I got to find 8, 12. So this was at 4. So I can go 1, 2, 3, 4. So there's 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's my new B. Oop, had a little skip there. There's the new B. And then finally at 12, 8. So again, I know this was 8. So 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8. Here's my new C. And I'm going to try to draw some straight lines here unsuccessfully, but it was worth a shot. there's my dilation. So I made this triangle much larger. Now notice how these angles right here, they did stay the same. Okay, this angle stayed the same. So the triangle actually maintained the exact same shape. Okay, but what it did is we just made it, and we just enlarged it. We made it bigger. I'm done. There's nothing else to do here. Okay, this is all of you need to know about, pretty much about dilations. Okay, up to this point. So let's look at another one here. So I have the vertices of the image quadrilateral ABCD. So it looks like I have a square. Each side length is 3. Sweet. Scale factor is 3. So another way to write that, if I want to write it algebraically, is my dilation is just taking my x and my y and multiplying both of them by 3. So I need to know what my original points are. So I'm going to write those out here. A, B, C, D. R, A is 1, 1. That's going to be a nice and easy multiplication. B is 1, 1, 2, 3, 4. And C is going to be 4, 4. And D is going to be 4, 1. Okay? So then I need to actually perform my actual dilation. Okay, and this is where I am using my scale factor of 3, and I am multiplying both my x and my y by 3. So this is going to give me my new A, 1 times 1, 1 times 3 is 3, so on and so forth. My new B is going to give me 3, 12. My new C is going to give me 12, 12, because 4 times 4 is 12. And my new D is 4 times 3, which is 12. So I have 12, 3. Now I can actually plot my points. 1, 2, 3, 1, 2, 3. Here's my new A. And then I have 3, 12. So 4, 5, wait, I lost my count. 4, 5, 6, 7, 8, 9, 10, 11, 12. Boom. All right, now I know it's going to be over this way, so I got to figure out where 12 is here. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So yeah, bigger graphs, that's for sure. And I know because it's a box, it's going to be right here. And there we have it. Let's see if Gradius can draw a straight line. But, so now we tripled the size, or we dilated it by a scale factor of 3 is what I should say. And I enlarged it, maintained the same shape. I'm all done. Now, notice how we just enlarged it. You will also have to shrink it or reduce it, okay? When we know it's a reduction is when our scale factor, it's not a negative number, but it's a number that's less than 1. So it's going to be a fraction of less than 1 and in between 0. Okay, so it's going to be a fraction. It could sometimes be a decimal, but it's a decimal that's less than 1. So it's got to be a decimal that's 0 point something, or it's going to be a fraction that's less than 1. Okay, so yes, we do need to multiply fractions a little bit, but one thing I want to point out is multiplying by 1/2 is the same thing as dividing by 2, which is why that gives us the reduction. So if I look at all my original points here, this is a pretty large image. Okay, so 1, 2, 3, 4. So my first A, my original A was at 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So is that 4, 10. Now my original B, let's see, this is at 4, 10. So that means this is going to be at 5, 6, 7, 8, 11, 12. So 8, 12. Just kind of cheating ahead a little bit, so I have to count all of that a little bit. And it's going to be at 9, 10, 11. So I was at 12, and 1, 2, 3, 4. And then my new D is at, we know it's at 8 because it shares where B's at. And it's at 2. So again, when I'm performing my reduction, I'm multiplying all these by 1/2. So it's going to be 1/2 x and 1/2 y. Well, the nice part about 1/2 is I'm really just dividing by 2. But if I need to actually multiply by 1/2, I can actually do that off to the side. I could say, okay, well, 4 times 1/2. Let's see, these cross simplify, and I get 2 over 1. So this is 2. Okay, 10 times 1/2 is going to be 5. For my new B, I'm going to have 4, 6. I'm just dividing these by 2. for my new C, I'm going to have 6, 2. And for the new D, I'm going to have 4, 1. There's my new points, and now I can plot them on my graph. Okay, 1, 2, 1, 2, 3, 4. 1, 2, 3, 4, 5. There's my new A. I should maintain the same shape. 1, 2, and then it should go up 1. There's my new B, because that's at 4, 6. C's at 6, 2. Whoop. There's 6, 2. And then 4, 1, 1, 2, 3, 4, 1. So I shrunk it by a half, by a scale factor of 1/2. Okay? All right. I've got one for you to try on your own, and then this will be the last one. So go ahead and give it a shot, see how you do, and then we'll move on. Okay, so I do have a quick joke for you. All right, where is the best place to do your math homework? So where is the best place to do your math homework? A multiplication table. Get it? You got to do it on the multiplication table. It's brilliant. All right. So here we go. Triangle ABC. I need my original points first. Okay, and then we can use the scale factor of 1/3. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So that was at the point 6, 6. Then we went over 1, 2, 3 up 1, 2, 3. Oh, that's nice. So now B is at 9, 9. And then I know A is at 6 is my Y because it's the same Y value as A for C. And then it goes over 1, 2, 3, which means it's at 12. Okay, so now I've got to perform my dilation, which means I'm really multiplying everything by 1/3, which I know is going to shrink it because it's going to make it smaller. It's going to reduce it because of the fact that it's a fraction that's less than 1. And so really multiplying by 1/3, if we look at this, 6 times 1/3, that is 6 over 3, which is just 2. That's really 6 divided by 3 is what's happening here. So I get the point 2, 2. I'll get the point divided by 3 is 3, 3. And when I divide these by 3, I'll get 4, 2. So there's my new image. There's 2, 2, 3, 3, and 4, 2. Made it much, much smaller. Okay, but it's still the same exact shape. And there's my A, B, and C. We've just made it smaller. We still have the same angles here. Okay? And that's it. So I hope this video helped. Good luck. Thank you for watching. And if you have any questions, let me know. Gradius out.